Hello, I'm Lorelei Wise, and this is a rubber band with some paper clips on it. It is also the universe. I'll explain. You probably know that the universe is expanding. That's what these paper clips represent. Galaxies appearing to speed apart from each other as space itself, the rubber band, expands, increasing the distance between them. You may also know that the culprit for this is called dark energy. But what exactly is dark energy? Well, the answer is we don't really know. Dark energy is just the term scientists use to reference the unknown force or field or something driving the accelerated expansion of the universe. But beyond that, we don't really have anything concrete, although we do have some theories. The first and most well-known of these is called the cosmological constant because that's what it is, a constant throughout all of space and time. It appears to get its energy from quantum field theory, which states that empty space is filled with constantly appearing and annihilating virtual particles. It all seems to work out really nicely. One major problem. Quantum field theory predicts a value for the cosmological constant that is 120 orders of magnitude larger than it appears to be. So either something's wrong with quantum field theory, or the cosmological constant isn't dark energy. Another major theory, called quintessence, is almost the exact opposite. Its key characteristic is that it's dynamic, changing in strength across space and time. This would solve another issue with the cosmological constant, the Hubble tension, which suggests that dark energy has increased in strength over time. It would also align well with a recent study published in March 2025 by the Dark Energy Spectroscopic Instrument, which suggests that although dark energy has increased in strength up until now, it's now starting to weaken again. Of course, there are other theories. Perhaps dark energy comes from black holes, or a flaw in general relativity, or a fundamental misunderstanding about the structure of the universe itself. But whatever it is, scientists can agree on one thing. It could lead to the end of the universe. Up until the discovery of dark energy in 1998, the Big Crunch, in which everything collapses back into a hot, dense singularity, was the dominant theory of the end. Dark energy appears to take that off the table, but if quintessence or another dynamic model is correct, that could still be possible. The Big Rip is another end associated with quintessence, as it involves dark energy increasing in strength until eventually it overpowers the strong nuclear force ripping apart even atoms. By contrast, the Big Freeze is associated with the cosmological constant. You know this one. Everything drifts apart until stars can't form anymore and only black holes are left, and eventually, even those decay, leaving behind a cold, dead, empty universe. But all of those are at least billions of years away. For now, scientists are still fighting to understand what exactly dark energy is, and until they do, we'll never know how it'll all end. So for now, this is the universe.